Hi everyone, in this video we have to learn about the pipelining in a detailed manner. First we have to go to the definition of pipelining first. What is pipelining? First we have to know the definition of a pipelining, that is decomposing a sequential process into a sub-operations with each sub-operation being executed in a dedicated segment. That means our process should be divided into n number of sub-operations. That sub-operations can be done by using a dedicated segment. Here segment means a hardware component that operates concurrently with all the other segment. That means at a time one segment is not executed. Whenever one segment is executed, in addition to that segment, all other segment is also concurrently executed. That is the pipeline. That means decomposing a sequential process into sub operations. That means a whole process can be divided into sub operation, that each sub operation can be performed with a dedicated segment. Dedicated segment means a dedicated hardware component. For example, I will take addition of multiplication of two numbers by adding a third number. I would like first of all we will store the a value into one resistor R1, and we would like to store the b value into second resistor R2. Then we have to, this is the segment 1, and we have to perform the multiplication process, and result should be stored in R3, and we have to store the c value into resistor R4. Next we have to perform the addition operation between R3 and R4 and store the result into R5. This is the one example of pipelining. So here we have to divide the entire process into n number of sub operations, and each sub operation can be done in dedicated segment. For example, this is one segment. So at a time we have to take the values of a and b. This is segment 1. Segment 1, after calculating of product R3 and stored in that value in R3 and R4, these are be taken at a time, that is segment 2. Next R5, segment 3. These are so our entire process can be divided into sub operations, and that sub operation can be divided, can be performed in dedicated segment. Here segments means hardware components. I will show the diagram once. First I would like to store the AI value into R1 resistor, R1 resistor, B value to R2 resistor. Next we have to perform the multiply. This is the multiply, is the combination circuit. Here multiplication operation can be done and store the result into R3. Store the result into R3. I will store the result into R3. After storing the result R3, at a time C1 CI నుంచి మనం R4 తీసుకోవాలి. R4 తీసేసుకున్నాం. So we have to perform the addition operation. So we have to use the combinational circuit, that is adder. After that adder, it perform the result, and the result should be stored in the R5. This is the example of the pipelining process. For example, in order to achieve the pipelining, I would like to show some example. Here I will in first iterations I would like to store the results of a into R1 and R2. After that it should go to the multiplier. After it calculate the R3, in that step, in next iteration, that the value should be stored in a, next value should be stored into a and b. So the one process is continuous, other process, next process will be ready for the execution. For example, I will take I will take some tank. Here A, some tank B. I will should connect a pipe between the A and B. From that water is goes to the A to tank to A B. If first drop is ready to drop, the next drop is ready to execute, ready to drop into a B table. This is called the pipelining. That's why here one instruction should be ready to execute, next instruction is ready. After execution of first instruction, second instruction must be executed. This is the concept of pipelining. I will show some example here. Clock pulse time. First in iterations, first we have to take the a1 value, b1 value. After that we have to take the a2 value, b2 value. Next this goes to the multiplier and go to the multiplications. After that we have to access the or fetch the c1 value. After that we have to achieve the r3 value, b3 value, a3 value. Next we have to do the multiplication a2 and c2. Next we have to perform the addition and show the result r5. So the if the first instruction is ready to execute, next instruction is to be ready to execute. After that first instruction completion, the next instruction is to be ready to execute.